Hey, what's up, guys? This is Chung here. So this time, LeetCode number 1847, closest room. Okay, so you're given like n rooms in a hotel, right? So and each room is represented by a 2D integer array, where the first element is a room ID, and the second one is the size of the room. And then you're also given like k-queries, right? Where the first query element is a preferred room ID, and the second one is the minimum size this query is looking for. Okay? And the answer of the query is a room ID. Is a room such that the room of course has at least the minimum size, right? And the and among all those kind of available, right, the rooms that can satisfy this minimum size, we want to find an ID, right, that has basically the ID is closest to the preferred room ID, right? And if there is a tie in this absolute difference, we return the smaller one, right? This is normal. Yep. So, oh, and if we cannot find like such room, the room that can satisfy this the minimum size, we simply return -1, right? So here are some examples here. So we have 3 rooms here. This room has ID 2, 1, and 3. So the capacity or the room size is 2 to 1. They're all 2s. And we have these queries, right? So the first queries, the preferred ID is 3 and the minimum size is 1, which means all 3 rooms are satisfied, right? With the current one, with this one, and with the 3, we want to find the closest one, which is 3, right? So because the difference is 0, that's why we have 3. And for the second one, since the size, the minimum size is 3, and none of the rooms satisfy this 3. That's why we have -1. The third one is 3 because the 2, for 3 for 5, right? So the last the preferred room ID is 5, and 3 is the closest one. That's why we have this one. Cool. So and here are some like constraints. So it's pretty standard 10 to the power of 5 right, constraints. I mean, this one, obviously, right, we want to sort, right? Because so because one of the reasons we want to sort is because the first, we for this kind of query problems, we have seen several like answer k queries problems. Usually for this kind of answer k queries problems, we always want to sort these k queries so that we don't have to so that we can basically process a condition, right? An element in one direction, and we don't have to go back to reprocess the some data, right? So in this case, so what's going to be the sorting condition here? Is it's obviously is this minimum size, right? So what does this mean? It means that we have a bunch of rooms, right? And we have this minimum size. And if we can sort the queries from the biggest to the smallest room size, right? And then, so the reason we want to sort by the minimum size is because when if we sort from the biggest to the smallest, by the time we are at a smaller size smaller size, we will have more like available rooms for us to search. Yeah, because every time when we have like the minimum size, we're gonna find all the rooms, right, that satisfy the current minimum size. Because if we want to find a room ID, that's the first step we need to do, right? And if we don't sort it, basically we have to for each of the query IDs, we have to somehow search all the rooms, right? But if we sort the queries IDs, queries in the descending order for the minimum size, so by the time we're at like smaller minimum, the minimum size, what those available rooms for the bigger minimum size, they are definitely will also be available for the smaller minimum size, right? That's why we sort the queries from the biggest by the minimum size in the descending order, right? So that basically at each of the minimum size, we're gonna find the rooms, right, that satisfy the current size. So then naturally, right? So when we find the rooms can satisfy the minimum size, since this one is sorting, right? If we don't want to reprocess the rooms multiple times, we also need to sort the rooms by the size, right? So that every time once we add rooms in our list, we can call it whatever we want. We can call it like available rooms or candidates, whichever you prefer. And then we know, okay, that rooms will be available for all the remaining queries, so that we don't have to add that rooms multiple times. Which means that our available rooms or candidates list will always becoming bigger and bigger, right? And in our like a candidates list, once we have the candidates list, right, we want to find basically a room ID who satisfied the second condition. Because in our candidates list, right, candidates list, all we're gonna save is the IDs, basically the room IDs that satisfy this minimum size, right? But in order to find it, we want to somehow sort this candidates list, right? Because in order to find these IDs efficiently, we want all those kind of IDs to be sorted, so that we can find the basically the ID that has the smallest a difference. Because if it's a sorted ID here, and then we can just use binary search to find like a place, right, somewhere here where the absolute difference between some number is minimum, right? Because we have to find that. But after that, and after that, we also need to consider maybe two candidates, maybe the one on the left and the one on the right, to make sure we find the ID that has the smallest, right? Because if this one falls in the middle, we want to check both sides, right? But that's going to be another thing we need to be considered. So which means now let's go back to these candidates, right? We want to make sure this one is sorted. So for that, we have to use some of the a different special data structure in Python, at least, because every time when we add like a new rooms into this candidates list, we want to keep them sorted. So in Python, we have kind of a sorted list, right? We have this one that can give us like a log n time complexity to either do so all the operations in the sorted list is a log n, right? We can use this one, but this one we have to import sorted containers package, or we can use like what? There's like a bisect, there's like a bisect insort, right? This one we might also be able want to use it, but this one will also pass all the test case. But in reality, this bisect insort, the worst case scenario, the time complexity is O of n. It's not log n. But still, if you use this one to maintain the orders, to maintain the orders in these candidates, this one can also pass. I can only say that maybe the test case is not like strong enough. But anyway, so we're gonna use this sorted list to maintain this one, and then we're gonna basically do a binary search on that. Yeah, so that's basically the idea here, right? Cool. So let me try to start coding here. Okay, so like I said, we want to sort both the rooms and the queries, right, by the size in the descending order. Okay, so first let's sort the rooms. We want to do a sorting. I'm going to do a lambda function, right? So it's going to be x dot. We want to sort by the second element in the descending order. So which means it's going to be a negative x1. That's how we can do the sortings. And second step will be sort the queries. But since we also want to populate the final answers, we're gonna also maintain the original index when we are doing the sorting. It's gonna be queries. That's why I'm going to add this original index into this queries before sorting. And since we're going to sort by the minimum size, right? Let me see. I'm going to put it into the beginning, right? So and the query, and then the 0, and then the I, right? That's going to be the original index. So for I, we have the query, right, in the enumerate queries. Okay. So basically, we add this the original index into the query, and then we also like put this minimum size at the beginning so that we can sort later on. Then we do the sort, right, and then we simply do a reverse equals to true. I mean, we can also use this lambda functions, right, to do it here. We can always use like a key. Let's do this. X0, right? This one also works. Actually, we don't even have to swap this one, but anyway. So, and then we initiate the answers. Everything starts with -1, right? It's gonna be a length of the queries. Okay, and then we're gonna have n is gonna be the length of rooms, right? And then I'm going to have like a j, right? J is gonna be the from 0. Basically, this j keep pointing to the next rooms we want to check. And the last one is the candidates, right? The candidates are, which is going to be the sorted list. Like I said, in order for us to use the sorted list, we have to import like a package. So from sorted containers, right? Import sorted list. So now we can finally start checking the queries one by one, right? So for queries, we have minimum, right? The minimum size, and the second one is the preferred ID, right? So since I swap this sequence here, and then the last one is the original index, right? In queries. Okay. So first we add rooms, right, to candidates whose minimum size is either equal or greater than this minimum, right? Basically, while j is smaller than n, and then so j plus 1, right? And then while smaller than n and the rooms, right? J of 1, right, is either equal or greater than m. Then we do a candidates, right? Candidates dot add. We only need the room's ID, right? Which means it's going to be the first element. Okay. And what else? So now we search, right? Search the room ID from candidates. So first we check if the candidate is not empty, right? Otherwise, we simply skip that. So we do a search, we do an index, right? So the index is going to be a candidate dot bisect. This is a bisect left. Actually, bisect left is equal to the bisect. It's going to be we search the preferred ID, right? But here, like I said, we ideally we need to check both side, right? Let's say we have 1, 2, 6, 10, right, and then 12, right? So this is the candidates. And if the p is what? P is like 7, right? So if p is 7, so which index we'll have? We'll have like this one. We'll have index is pointing to this one, right? Since we do like bisect left. But for 7, 7, if we just use index for this one, we'll have like 10. But our the better answer is 6, right? So which means that besides the index, we also want to check the index minus 1. That's going to be the two candidates we want to check. But there are like some other like edge case, because when we do the search, the index could be could be index 0, or it could be at the end of this list, right? Because let's say if the p is, let's say this is not a 2, maybe 2 and 4. Okay, if the p is equal to 1, right? So in this case, the index will be 0, right? And the index minus 1 will be minus 1. In this case, the index minus the other candidate is not valid. Same thing for like if the p is equal to 20 or is equal to 15. In this case, index will be out of the boundaries, right? Instead, in this case, index minus 1 is the only option we have, where the index is an invalid case. And basically, we have to handle that, right? This different special case. I mean, you can use your own way, but I'm just going to code the way I do it. So since we have 2 candidates we want to consider, I initiate them to candidates 1 and 2 with the system max size, right? So the reason being is that later on we're gonna use this one to do a different absolute difference with the p. So if I initiate, and then we're gonna choose the ones who has a smaller absolutely different, right? So if we initiate with the system max values, the ones that it's not valid will definitely not have like a smaller absolute difference. Okay. And so the candidates 1. Okay, so maybe the candidate 1 is index, and the candidate 2 is index minus 1. Okay, so for each of them there's like an invalid scenario. Okay, so for index 1, for index, we set the index when the index, so we set the candidate 1 when the index is smaller than the length of the candidates, right? This means that this index is inside this candidates. This is when we do the candidates 1 equals to the candidates dot index, right? And then for the candidate 1, for candidate 2, we set that when the index is greater than 0, right? This is otherwise, the candidate 2 will be a negative value. This is when we set the candidate 2 equals to the candidate of index minus 1. Okay. And okay, now we want to check the absolute difference for this kind of 2 candidates. And another thing is that we have to be consider is that if there's a tie, if the difference is the same, then we want to use the smaller ID. And which one of these 2 is smaller? The candidate 2, right? Because the candidate 2 is index minus 1, and this candidate is sorted, right? That's why we need to do something like this. So basically, if ABS of the candidate 2 minus p is either equal or smaller, right, than the absolute of candidate 1 minus p. So and then I'm going to use the candidate 2 in this case. Otherwise, candidate 1, right? Right, because here, I'm using this kind of like smaller or equal sign here when there's a tie. Then I use a smaller one. Otherwise, I use the other one. So here I return the answer, right? So that's it. Cool. So run the code. Oh, there's a typo, I think. Query er is here. All right, accept it. Submit. Candidate 2 refers. Huh? Oh, so many typos. Sorry about that. All right, cool. So it passed, right? Yeah, I mean, oh, the time complexity. So time complexity shouldn't be that hard to analyze, right? So let's say we have this is n and k, right? So the rooms is n. So to sort the rooms, we have what? We have n log n, right? So n log n, and then we have what? We have k log k, right? K log k sort the queries, and then here we loop through the query, right? Basically this is going to be the k, right, times what, and we add this candidates. So the candidates is going to be the number length of n, right? And since this one is a log n, so it's going to be a k log n. Yep. Oh, and here is like another bisect, right? But here, since the search, it's also like a log n, right? So this one doesn't change. Yeah, basically that's the total time complexity. A lot of log n or log k in this case. Right. So that's pretty much it is, right? I mean, so the key thing for this problem is that we have to somehow sort, find a way to sort this both rooms and queries, so that for each queries, for each of the queries we'll only add the available rooms once into this candidates list, right? Based on this minimum size, right? And after that, once we have candidates, we can simply just do a binary search. And since we want to do a binary search, we need these candidates to be sorted. That's why we chose to use the sorted list in Python to achieve that. And the last things that we have to consider this two candidates, right? The smaller one and the bigger one, but those are kind of minor things, right? All right, I guess I'll stop here, and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.